Hi everyone, welcome to this podcast, Tech Leaders Hub. I am Sridhar Jamal Madka, India's first next-gen full-stack AI coach, and I'm founder of Tech Leaders Hub. Today we have a very special guest with us. I'm so excited. His name is Kausal Malladi. He is the Senior Vice President and Head of Engineering Stocks at INDmoney. So he's someone who is deeply involved at tech leadership and financial systems. So I think we'll have a very interesting conversation which will resonate with our viewers. So great to have you, Kaushal. Welcome to the show.
Thanks, Sridhar. Thanks for having me, and the pleasure is mine.
Yeah. So let's get into one question. So our viewers are mostly developers who want to transition to tech leaders role. So here is my first question for you. So you moved from coding every day, being an individual contributor, to now leading an entire engineering teams, right? So how much coding do you actually do these days? Is there any coding that you do at all?
Yes, it just kind of narrows down as you progress. In the initial days of building the InStocks platform, I used to heavily code a lot of stuff. Lots of bare bones, lots of frameworks are all written by me, and then the team was there to develop it and then extend on top of that. Yeah, but today, yes, I get a lot involved with the design, lot involved with architecture. I also write a little bit of contracts whenever there is any new thing, so that people can develop on top of that. But a large part of my time goes into design and architecture and helping teams solve for scale.
Okay. So tell me something. For somebody who is transitioning from individual contributor role to a tech leadership role, how do you suggest balancing coding and management and design? All of this.
Yeah, if you don't do coding and if you cannot really excel in the coding, you cannot. My view is that you cannot win while leading the teams, because we need to understand in depth about all the frameworks, about the pros and cons of every design and architecture, and not. So this is what I keep telling in my life, right? So there is nothing right, nothing wrong in an architecture, right? So it is all about what is the most optimal thing for the use case that you are building with. So there is nothing like a textbook for architecture. So someone should be aware of what are all the pros and cons of each choice that comes up as part of the process, and that choice, once we transition into the leadership roles, plays a significant role in making the right decisions, and then those decisions transition into making the system scalable. So if the systems are built scalable, if the systems are built reliable, then it means that the engineering leadership behind that is actually in the right shape. So my view is that while someone is actually starting to code, the larger part of thinking should be there, not just for the smaller part of the code, but the larger part of thinking should be there around the scalability of the systems, around what is right in the context of the things that I'm doing, and what can be something that I do better. So here is one thing that I wanted to share, right? So, I think someone was telling me, if I'm able to do something better than what I was doing yesterday, that's what it matters, right? So yesterday I have taken a decision, and then maybe it is not the best decision in the world that I have taken. But today, if you are able to rethink and come up with a better solution and then make sure that it helps you in the long run, and as long as you're able to do day on day, week on week, and quarter on quarter, that is when you end up building better teams and evolve yourself into a better leader, from transitioning from all the way from being a coder to, let's say, IC to a leader.
Okay, that sounds interesting. So I see that you've changed a lot of domains when I spoke to you. I understand. So can you talk a little bit about it? Like, is it a good idea to switch domains? Right. So do you recommend that? Because there's one school of thought that says that stick to one domain. There's another school of thought that says it's okay to switch domains. So what is your view on this?
I mean, my view is that we need to explore multiple things in the world to be able to be a full tech leader, to have the 360 view on multiple problems. So from my personal experiences, yes, I was initially with Infosys, then I did my master's, then I joined Intel. And when I worked with Intel, I was working on the display drivers for the Android devices. So it's actually part of the Linux kernel code. So, my contribution, some part of that is also there even now in the Linux kernel. So the point here is that when I was doing that, I really enjoyed doing that. And then it was my stint with Intel was about a year and a half. I thoroughly enjoyed, but at some point of time, I asked myself, will I be happy or will I be motivated doing what I'm doing today for the next 30 years? So the straight answer that came to me was maybe not. So the answer was never yes. So the answer was possibly no or possibly maybe not. So in either of the cases, then I felt maybe I will get demotivated doing only one thing for longer period of time. So that is when I tried exploring multiple stuff. And then, then I chose to work with Goibibo. I joined Goibibo in 2015. And when I was working with Goibibo, we were a small company at that time, almost in a very good growth phase. And I have had chance to build lots of real content that gets powered on the website through these multiple external API integrations and all of that. That was a completely different paradigm shift from what I was doing with Intel. And that's when the connectivity to the cloud and then all the cloud services and then scalability, all those problems, and then all of those came up. And then I started learning a lot of those through the solutioning. I started learning a lot of stuff on scaling systems at that point of time. Then I of course built a very good discounting system for Goibibo, and then which was later adopted for Make My Trip as well after the Goibibo got merged with Make My Trip. So that was we used to call it Manthan. So we used to, a lot, like the name resonates, a lot of thinking went into building it, because that's the bread and butter for what we were for our organization there, and because it's what earns and burns, right? So what is the right mix of earning and burning? And then of course we have had chance to work with cross functional teams from cross businesses. It's not just one business, right? It's cross businesses, because Goibibo and MakeMyTrip used to have lots of businesses. Even now they do, right? Hotels, flights, and cabs, and then multiple teams, and then inside them all the multiple revenue teams, business teams, and the product teams, and everyone. So that gave me a very good view of how to build systems in collaboration with cross functional and cross business teams. Then I wanted to really try out something from scratch, and that's when an opportunity from INDmoney came by my way. So we started building in stocks. So, and with in stocks, we were one of the brokers who could build the entire broking business and then take it live to the external users in a very short time. I think in about 8 9 months we were able to add lots of external clients and then fully scale up further, and then keep iterating on top of that, keep adding lot more products, a lot more solutions to people. And that's how the whole evolution happened. And then in this whole scheme of things, one thing that I keep telling everyone around me is that every step of this whole journey has been giving me cherishing moments, in a sense that I learned a lot of stuff, and then I have been able to impart that to some of the people who are working with me, and at the same time have a view of the systems, that what all it takes for building the systems, and how not to be building the systems. That is more important. How to build systems you can always find by reading some blogs and everything, but how not to build is something that you can only get to know with a bit of experience. So
Experience.
yeah, that's how the entire switching of multiple domains helped me.
People don't talk about their failures often. They don't blog about failures often. Right?
Yeah, I mean, everything is important, right? So
Yeah.
in building a business, you would like I said in the initial part of this discussion, right? So you make mistakes. So as long as you are able to think better than what you were thinking yesterday, that's good enough. At least it tells you that you are on the right path, and you make mistakes and you course correct. And then when you course correct, you know that okay, next time when a similar problem comes up, you know what choice to actually make. Yeah.
Okay. So what happens when there is this perfection syndrome that comes into picture? Is that going to affect the decisions?
It does. I mean, you need to definitely you want to make every decision perfect, right? So the intent should be that I make all my decisions perfect. But at the same time, is it possible 100% of the times? No. But but to make it possible, let's say to the majority of the times or closest to about 90-95% of the times is what differentiates successful engineering leadership versus not so successful engineering leadership. So there can never be 100% perfect things. You need to be able to achieve somewhere closer to that, and quickly understand that something works, something doesn't work. And then we need to be able to know that, okay, this is something that is not going to work. Let's say you have developed some software today, you have come up with some service, and then you have come up with a very nice architecture in the scheme of things that you have in the people in discussion with the people that are around you. But week later, if you are able to realize that, okay, this is not going to work, we should not be thinking twice to change it just because I've already built it once, right? So this is what I learned from my CEO Ashish Kashyap, right? So he always says fail fast, right? We should try and experiment and fail fast. In case something is not working out, we need to try different ways out, right? So this is my way that I have, this is my view on, having perfection or close to perfection in the engineering leadership.
Yeah, that's interesting because I see a lot of times software developers or designers or architects, when they take a decision, they somehow become very attached to it, and then they try to stick to it instead of taking the feedback and course correcting or changing it if it's needed.
Yeah, this is what I used to tell in the initial days of when people joined my team, initial days of those, I used to tell this to my team, right? So don't attach yourself to the code, right? That you don't attach yourself to the code that you write or to the product that you build, because you never know if something is not working. We might want to scrap the code, and then, for example, recently we had to scrap some of the initial services that we all wrote in the initial days of building in stocks. So it means that we need to evolve, and then when we are evolving, you need to decouple yourself from what you've already written and then think forward.
Okay. So, talking about technology choices, I worked in an investment bank for a couple of years. I saw that Java is very popular in investment banks and banking and finance. So, what do you think? Where are we heading towards? I mean, is Java still the favorite language, or has the industry moved on? Or what is your view of what are the kind of technologies that we should embrace in finance and in the investment banking area?
See, Java is, I would say, still the one of the most sought after languages in the industry, primarily for two reasons. One, there are a lot of systems that are legacy built, and then people dread touching those. So that's how it continues. And two, it also has very good capabilities in terms of concurrency and everything else. So it's not that there are many new languages that came up, and it's not that Java has not caught up. And then there are very good things that we can develop using on top of Java as well. But if you ask in today's world, I think a lot of paradigm shift has happened into the new age languages. I think one of the favorite languages of many people that I speak to today, and including mine, is Golang. Right? We use that quite heavily. And then with Golang, what I observed, I developed systems in multiple languages previously. With Golang, what I learned is that because it is very thin, and then because it consumes lesser operating system resources, you can actually run on very little infrastructure. So the Go runtime doesn't need a lot of infrastructure, unlike many other languages. So it helps you in scaling for systems, because it also has the very good capability of inbuilt capability of concurrency using these Go routines and everything else. So it helps you with lots of scaling problems. It helps you to problem when I say problems at scale, two types of problems. One is the correctness problem, and the other is the throughput problem. So when you have lots of throughput coming in, that is when your efficiency to be able to respond that on your server, to be able to respond to all those requests in shorter time matters. And then you don't want to throw infra to the problems all the time. So you need to always try to work on smaller infrastructure, or optimal infrastructure, if I may call it, and ensure that you are still able to serve with very good latencies to the user. So, for example, in the systems that I've built, both in the previous company and here, we all talk only in terms of single-digit milliseconds or even lesser, right? Sometimes in microseconds and sometimes in nanoseconds also. So all of that is possible because of right choices. And right, one is right choice of language. The second thing is the right choice of configuration inside that as well. What what version of the language do you use, what configuration settings do you use, how many go routines do you want to use for this specific use case, and if you use X number of go routines, and when you get a traffic spike, how does that spike in go routines happen with regard to the spike in the traffic? And you don't want to, leak lots of memory, right? So a lots of these systemic things come into the picture while building systems. So as part of the language choices, while language choice is one significant part of decision making for building systems, it is not just the language. It is also about how you use the language that matters the most. People can still use the best language in the world and then still write worst code. So how you write code in the same language, and how you make the code extensible. And for example, this is what I used to tell lots of people previously also. If you write code today, and you're not able to understand that code, let's say after one week or 1 month or 3 months, then it is a big mess that you are in, right? And it is also that it is not just you that you will understand. That it's not that, okay, every code comes with a person who explains that. There should be obviously a bit of knowledge transfer, but you cannot essentially have people explaining it. Code should be self-explanatory. That is, and then with those ideologies, systems can evolve better without much of redoing. You don't want to, in a startup kind of a world, you don't want to spend time redoing stuff or rethinking about the systems in all cases, right? There will be those 4-5% of the cases where you will do, depending on how the systems evolve, but you don't want to do it for 90% of the cases, right? So the choice of language, and what kind of frameworks you use around that language, and what is the ideology with which you help your teams code, all of these matters, in my opinion.
So, as a person, I see that as a developer, you worked in Intel, right? And you worked in multiple companies like that. So, what are the different technologies that you came across, different programming languages you came across, different stacks or different frameworks that you came across?
Yeah, initially when coding in device drivers, we used to write a lot of code in C, C++, and then even testing of that code also was quite challenging because you have to test on some external devices connected to your device and everything. So that was a different ball game altogether. Later, when I shifted to e-com and then fintech, I came across lots of different problems for which we have chosen the right tech stack. So Python was one of the things which we used to develop lots of code in the initial days. Then we moved transitioned, and then we also had lots of NoSQL because lots of unstructured data was there. Then we transitioned ourselves into some transaction systems, and then where we used Go and then Aerospike quite heavily. That helped us in scaling for high throughput and with low latency. Then as we further transitioned, Golang became the mainstay, and I mean, for all the transactional use cases, we use Postgre. And, for non-transactional use cases, for unstructured data use case and multiple other use cases, we use DocumentDB, DynamoDB, lots of async messaging world. We use Kafka, SQS, and then of course Redis caching is always there. And lots of, now that, the front ends are all there in Kotlin and then Swift and then React. So we have, in this last 15 years, I've had chance to work with lots of the entire gamut of the tech stack from all the way from 2010 till today. So that gave a very good exposure towards building systems, not just in one single language, but also building systems and the ideology that we should be adaptable and making our tech stack choice adaptable to the systems that we are building.
Okay. I see a lot of developers getting very confused, right? The freshers on one side and also the experienced people who have like 3 to 5 or 3 to 8 years experience, SG1, SG2. They keep getting confused like whether whatever technology that I chosen is the best. I mean, will it keep me in market for long? Is this the best choice or should I be going for the latest technologies? So what is your advice for them, who are looking forward for some advice to
Yeah.
stay in the game? Yeah.
So in my advice is that in the first few years of being just a software developer without, let's say, additional responsibilities of leading teams or mentoring coming into the picture, it is always good to first get the depth into the systems. So first depth and then breadth, right? So let's say someone chooses Java. So it's always good for him to know in depth. So when someone knows things in depth, it could be not just programming languages, but even the other tech stack, right? Let's say Redis or even Postgre or anything, right? So people have to go into the depth in the sense that to the level that they understand, let's say, how indexes work, and then what is the best kind of index that I do in this kind of use case. And to be able to achieve the depth, we need to ask questions, right? A lot of times when I speak to people, when I interview candidates, if I ask them why do you think Java was used for your programming language as a choice of programming language, they say no, I don't know because people were using it and I continued it. Maybe you were not the decision maker, but it is good and then it is right to also have the understanding about why we are using one language or one database choice over the other, and then that helps in getting the depth of the knowledge. And once we have depth in one programming language, then having or expanding the breadth is not a real problem, because the ideologies of any programming language, the core ideologies will remain the same. Every language will have its own different things which are unique to itself, but the core ideology remains the same. Like how the computer science basic remain the same, which depending on how you code, the core ideology of any language is to be able to run your instructions on the chip, right? So that's what it is. It boils down to. So once we get into that level to see how my code is working, then expanding the horizon to the other languages and other tech stacks is very easier. So my advice when I speak to people is that get the depth in the first few years, and its first 3 4 years 5 years is the most important time in anyone's life, because you have very lesser things to do at that time. Only one thing, just code and then just try to see how it goes to production and then monitor. But you don't have the additional things like mentoring people or building teams and everything else. Once you start doing that, your focus on learning new stuff obviously diminishes, obviously comes lesser, but it cannot be zero. It has to be there. Otherwise we will end up being no one in the industry after few years. But because in the first few years you have lesser things to do and then only concentrate on technology, it is good to use that time heavily to be able to go deep into the systems, then expand it to the expand the horizon through the breadth.
Okay. So I often see that, developers, they say that I'm a back-end developer, I'm a front-end developer, and so on, okay? And they often miss the big picture. So what do you think about it? Should people be focusing and specializing in back-end and front-end, or they should also be like looking forward to becoming a full stack developer? What is your opinion on this point?
I mean, they don't need to be a full stack developer in that sense, but my view here is that they need to know at least to some extent. Let's say if someone is a front end engineer, they need to know how typically backend systems are built and what are the complexities of building some systems, right? And similarly, the other way also, if someone is a backend engineer very passionate about writing high scale, high throughput systems, solving for scale and throughput, they should at least know what are the complexities that are there on the front end side of the things. Otherwise, what happens is that the bias of decision making will be towards the area that they are specializing in. So let's say they end up specializing in backend. So they only start taking decisions that are comfortable for them for the backend systems, which can perhaps be not so correct for, let's say, the front end system. So having a whole systemic view in terms of what is right for the system, and then what components are to be served from backend, what kind of handling should be there on the front end, and what mix of this will make my software extensible and also scalable, is something that people should start thinking. And that comes with not just by being, they don't have to be full stack engineers for that. They need to know how, and then regularly interacting with the other counterparts. If you are a backend engineer, interacting with front end, and front end interacting with backend, regular interaction with this engineers, and then also understanding how the systems are built will help in these kind of things, and then thereby build systems better.
Yeah, also adding to that, I also see that, the developers, if they do not have the holistic view, they're not able to debug the, issues, because they don't know where the issue has come from. Is it front end issue or back end issue, and they lose time in that. So if
Yeah.
somebody knows the whole system, they'll have some idea about where the issue is probably in, right? Makes sense.
Yeah, I mean, because this is a very good point that you brought up, Sridhar. In fact, when I ask people, how, okay, from the mobile device, you are developing mobile apps. In the end, the user is interacting through the mobile apps, right? So when I ask them, okay, can you tell me how is the packet going from the mobile user all the way to your server, to the server that you have built? People struggle there. So, with that, what happens is that they don't know how many hops are there in the middle. They don't know what kind of complexities come with with what hop. And with that, it finds, like you said, very difficult to debug the problems. So having a systemic view, and I think this is what I would say, right? Having systemic view and metricizing every line of code or every component that you're writing is more important, both on front end and the back end. If you don't metricize well, then you don't know, you know, you will have hard time debugging the problems. You don't know, let's say if you're trying to solve some latency problem, you don't know which part of that code is actually taking the time in serving the user's request. So in addition to the holistic systemic view, it is also important to have the right metrics.
Okay. So I have a question that, the infrastructure costs, they keep increasing, in the cloud systems. And developers, they take it for granted, the infrastructure. So what do you think the developer's view should be when they're developing systems or writing code, how it connects back to the infrastructure?
So it all starts with the college coding exercises that everyone does, right? So there is this code chef and then all this websites, lead code and all of that, where you actually code, and then you typically get what is called as time limit exceeded error, right? So it would be very frustrating for the people when they see time limit exceeded. Even I used to feel when I was in my college days, when I was coding, what is this? Why is this bothering me? At that time, it feels like a bother, something that is bothering you from making your assignment getting done. But as we grow, it is the most important thing, that we need to be thinking. So because a time limit exceeded inside your simple coding assignment means that you had a very bad choice of, let's say, a bad for loop running or a very bad time complexity of your code, right? So what that translates into in the real world when you deploy is the more CPU cycles or memory cycles, depending on what was the problem. So when it is more CPU cycles and more memory cycles, then your code naturally requires more infrastructure than what it is supposed to be requiring. So when your code is requiring more infrastructure, then you can never be optimal, right? So what happens is that as you scale, let's say you're scaling 2x, your infrastructure also should scale 2x. It is never something that is good for the business, in terms of, because every business has to have some amount of cost that you spend, and then the amount of revenue, and then the net PNL, right, that you get. So unless we think of PNL, businesses will not be able to scale, right? You don't want to run a loss making business. So when we are developing systems from scratch, we should also think what every line of code actually translates to, and then how each line of code or each choice that you are making or each network call that you're trying to make, what is it translating to, and then each byte that you are sending, over the wire, it also adds to cost, ingress and egress, right? So it also adds to a lot of cost, and then everything put together at the end, when you are heading engineering teams and leader and in some leadership roles, all the cost is also your problem, right? And then you need to be able to have that view of optimizing right from the college days, when you get that time limit exceeded errors, or even before that. So that's my view on this subject.
Okay, so are you saying that people should be looking at what is the complexity of their code? Is it exponential or is it n square or something like that, and try to fix the algorithm and make it a little
Absolutely.
more optimal? Yeah.
That is at the code level, and also at
Mhm.
the tech stack choice level. For example, lots of people use Redis for caching and everything else, right?
Right.
So do I really need to use Redis there, or can I do something with the in-memory caching itself? Because if I'm using Redis, people often forget the fact that while Redis is giving you sub millisecond, sub 1 millisecond latencies in very good cases, it also it also adds that network latencies, right? While the simple query on the Redis for whatever query it may be is responding in let's say a few let's say less than 1 millisecond. Your network to and fro is itself making it, let's say, 5 milliseconds or 4 milliseconds. So sometimes, should I actually make a network call? And it's also a right mix of choices, right? So you want to also have multiple microservices coming into the systems, right? It's called separation of concerns, right? You're doing separation of concerns, but at the same time you're also adding network calls. But separation of concerns is also important. Optimizing network calls also is important. So it's a balance that we need to strike whenever you are making any code choices or infrastructure choices or tech stack choices, to be able to achieve the right mix of all of this and achieve the optimal infrastructure costs.
Okay, so you brought about the point of microservices. Now I see that everybody, more or less all the companies, they're becoming obsessed with microservices architecture. That more or less whatever could have been a monolith, also they make it into a microservices. What is your take on this? I mean, did you face any problems with this kind of a view? What is your view on this?
So my view is that you cannot over engineer everywhere. You have to be engineering in an optimal way. So if there are cases where two systems are tightly coupled, and and those two systems cannot independently live without them being always coupled, in the sense that A has to call B all the time. And if both systems are similar in the sense that both have to, let's say, have similar kind of database calls and everything else, it might make sense to club all of both of them into one single system. But it's a choice. It's there is no generic statement that someone can give, but it's something that we need to be able to take decisions with experience, right? So with experience you tend to take decisions thinking, okay, am I over engineering here, or am I actually doing optimal engineering here in terms of distributing it across microservices? And then in my experience, there have been many cases where the usage of microservices across systems and then making systems decoupled helped me a lot. But it doesn't mean that that is the only right way of doing things. It also, monoliths also sometimes help depending on what kind of use cases. And today, even in fintech industry, I know a lot of systems are monoliths, and a lot of companies are run as monoliths even today. And they make a lot of money. They are one of the some of the go-to people, for all the integrations and everything else. They still are making money. So it all depends on what is the problem statement that we are attacking.
Okay, so let's talk about this. The developers, they dread testing, and they do a little bit of unit testing, but they somehow seem to be dreading testing or hating testing or something like that. So what do you think about this scenario? Why testing is really a big deal? Is that so important?
It is very important because when the code goes to production, it cannot fail. If I was playing around with my code in my laptop, that's fine, because it is just me who is running the code, and then I'm just trying to understand how it runs. But when you're publishing it, or when you're deploying it, and then when you are keeping it open for people to use the code, you don't want use the code as a service. You don't want to go down. You don't want to throw surprises. And then when you are in startup world or even in big companies, you need to be evolving the software. So when you evolve software, unintentionally bugs keep coming in. So it's not practically possible to manually identify and manually do a lot of testing and identify those bugs. So my view is that all the systems should have self-sufficient automated testing. So when you're writing code, you need to also write unit tests and also integration tests around them. And what this helps with is, well, let's say you have to change business logic tomorrow, then and you change it, and you make that running of the test as part of, let's say, some CI/CD pipeline, right? And it fails. So you know that, okay, I have changed something which it failed. So I need to also update my test cases, right? So business logics do change over a period of time. And with business logic, if this test case was not there, and let's say a manual tester was there, and then he was able to identify 95% of the scenarios, the remaining 5% of the scenarios would get missed, however good a manual tester is. And then so to be able to give 100% reliable experience and ensure that you don't leak bugs into production with all the changes that you are making subsequently. It is always good to commit the test cases and also make it part of CI/CD pipelines and then make them run before it gets deployed so that we are completely robust in terms of software management.
Okay, I see this argument all the time from the developers saying that unit test cases are not so important. I mean, because it's a waste of time. I want to finish my user stories quickly. So how do you convince them that unit test cases are important? Or what is your opinion or what is your advice for them?
I give this couple of real world examples. Lots of things happen, right? For example, last year there was this CrowdStrike outage, right,
Right.
which literally brought down the entire world for an hour or so, and lots of Windows based systems were out.
That's
um,
true.
right? So, I mean, with no disrespect to anyone, lots of testing would have gone there, and then lots of QA would have manual QA, and then UAT, and everything would have happened there. But what I do when people argue, when people feel demotivated to write essays, give these kind of examples, and then these kind of examples connect very well with people, right? People are very people are very they get connected with something that comes in the news very easily, right? Then that's how they understand the complexity that gets associated when your system goes down. So I think the way I do it is by giving these kind of real world examples. Lots of examples are there in any industry that you would take, lots of examples. So try to give them some real example about how a bug in the system brings the systems down, and then proper testing helps avoid all of that. you know if I do that, then I've seen people understand that and then start getting motivated to write tests subsequently.
All right. So let's go to the another territory. This is very interesting. Okay, this is about AI in the stock markets. So I've been hearing news that in future the stock market will be run by AI agents. So do you think that this is going to happen? Okay, we'll park that question. And even before that, can you please tell us how is AI coming into picture in finance these days? That's my question number one. Are they really helping in predicting the stocks? Okay. And then the follow-up question is, are AI agents going to take over the stock?
So AI agents are very significantly used in lots of fintech companies and also brokers to some extent to solve lots of these recommendation problems. And also for today, if I were an algo trader, I can actually go to, let's say ChatGPT and then ask it to write some code for me basis the data that is available publicly about, let's say, the historical, OHLCs of a stock. And then try to come up with a software that can give me some sort of touch points which I should be working with when I'm doing some algo trading. So these are some small use cases that individual algo traders and individual, even a regular individual can actually do. And coming back to your question, will the AI agents supersede or replace the brokers? I think it is very difficult because a broking is something that involves a lots of interaction with exchanges, and the interaction with exchanges are through the traditional TCP protocol over lease lines and everything else. So there, it's not just software; it's also a lot of hardware and the networking problem that comes into the picture. So yes, AI agents will not be able to replace the broking industry there in that sense.
Okay. So I have a quick fire question for you. What are the
Yeah.
three resources that you will absolutely recommend for someone who trying to become a tech leader?
Clean code,
Okay.
then I would say ownership,
Okay.
then metricizing.
Awesome. So how do you metricize? I'm curious to know how do you metricize as a developer, whatever you're doing, how do you write metrics?
There are lots of observability platforms these days, and then you
Right.
can actually find out through them, you can actually find out how much time my code is actually going to take and what part of my code is actually taking a lot of time. And apart from that CPU and memory profiling, you can also, I mean, CPU, there are, if you're, let's say, if you're using Golang, you can also use, let's say, pprof to be able to find what is your CPU memory profiling, code routine profiling, and everything else. Apart from this profiling, we also need to understand how much is the network latencies that are coming up. So when you start adding metrics everywhere and when you start tracking them very well, at a granular level, there's something called adding segments, right? So you need to know, if you start adding segments, you will know which part of the code is actually taking time, and then you need to know, let's say you have to optimize your response time by 10%. You need to know which one is the easier thing that you can attack, right? So if you have right segments and right instrumentation everywhere, it makes your life easier to identify the problems and also to understand the low-hanging fruits to fix.
Are there any specialized tools or softwares that you can recommend to the viewers which they can use for doing the instrumentation of the code performance, how it is doing?
No, in Golang you can actually do
Okay.
you can buy that. You will be able to understand how much CPU am I using, and then what is the memory profile, which part of my code has memory leaks, and what is my go routine profile, and which part of my code is leaking go routines, right? And that helps in making your code robust. And of course, there are lots of observability. I don't want to name because there are so many observability platforms. They help you in, identifying the response times and then tracking very well about how A service is talking to B, and then what is the overall response time for A to call B, and so on.
Okay. What is your top advice for developers who want to fast track their growth into leadership roles?
Yeah, I think working with a startup helps in that direction, because if you're working with a big company, yes, you will learn a lot about processes, and then you will learn about how to set processes and how to make sure that you follow the processes with right practices to be able to deliver things. So that is one side of the things. But in startup world, there is a lot of burning of midnight oil, and then lots of challenges because the teams are smaller. So everyone has to own up a larger component of the services than what they would have been otherwise doing if they were with a bigger company. With that, what comes is great exposure, and great exposure means you also, because and then there is also this ownership. So ownership with great exposure means that you're responsible for a very important system or a very important component of your system. Thereby you naturally tend to monitor it very well, and with monitoring it very well, you will understand also what are all the problems that are coming for the end users on the code. So you'll understand the bugs and everything. You will fix them. So the entire lifecycle management is something that you will learn. You will also learn how to deploy your code. How, it's not like, you push the code and then someone is doing the deployment for me. So I don't even know whether I'm running on an EKS or I'm running on an ECS, and then what is the best scenario for this, and then how much time my CI/CD pipelines are taking, how much is the build time, how much is the deploy time. All of that you get to know end to end when the teams are smaller, and when you are in a kind of a startup kind of a world, so that the learning is multifold and you end up reaching the leadership roles faster.
Okay, so a lot of my viewers keep asking me this question, that how do we apply for these roles? I mean, they want to work for startups, they want to work for different kind of companies, but they say that they're not getting calls. Do you have any practical tips or advices for them?
Yeah, I mean, first, how to find where there are openings. Today there are lots of this kind. There's soft websites where you can actually find the listings and then everything else, and even LinkedIn. People can follow LinkedIn pages, and then there is this job section on each of the company's page, and then they can find out. That is how to find. But how do you get the calls, right? So this is something that is very important, because then you should have done something significant. Then people tell me, okay, I don't have experience, right? Even if you were a fresher, if you had done some significant projects in your college in the initial days, and let's say even some hobby projects outside of your assignments, those add a lot of value and a lot of interest to the person on the other side who's reviewing the resume. So with that, people think that, oh, this guy is someone who is having lots of interest. Okay, let me try and spend time with him to understand whether he fits. So to be able to get there, you need to have some problems, very good problems solved, and that cannot happen with only following the regular curriculum if you're in college, or if you're outside of college, only just doing your official work. You need to be able to have some hobby projects, have some of the and then contribution to open source is something that catches eyes, right? So and then there are lots of open source languages in this today's world in whichever language you pick. Let's say you pick Java, Golang, Python. There are lots of open source softwares that you can contribute to and that we use really regularly, right? Let's say if you are developing on Java, without Tomcat, you will not be able to even deploy anything, right? So, and then let's say you identify some issue while deployment. You can always you can always say that, oh, I identified this issue. It may not be your code issue. It could be some issue at the time of running your server. Then you can actually go and I have seen people very enthused with going into the software open source software codes and then trying to identify which part of the code is something that is preventing them from whatever is the problem that they were facing, and try to raise a pull request to solve that problem, right? The fact that someone actually goes and creates an open source pull request itself is very significant. Whether it gets merged or not is a different problem, but to be able to understand the code and then do it. So those kind of open source contributions, very good interesting softwares, and then something significant, and then let's say if someone is working in the industry, how much eye do they have on their metrics, and not just someone saying that, okay, I have developed this versus I have developed this which resulted in my business growing X% is a completely different thing. So that means that person has an eye on the metrics. So those are all the kinds of things that people can do to be able to catch the right jobs in startup world, and then thereby learn faster and grow faster.
Okay. So, okay, I have a question because I do a lot of interviews. So, okay, I'm thinking on the side of the interviewer as well. Okay, let us say the interviewee, the candidate puts something like a claim like, I developed code which helped the software do something, or maybe the business get an outcome of this much percentage. Okay, how does the recruiter validate that?
Yeah, that depends on you cannot validate the statement that someone has actually given, because you don't know what is going there, what is actually happening inside the company. But you can definitely find out, as an interviewer, you can definitely find out by asking a few questions whether he has actually made the right claim. The number can be right or wrong. That's a different problem. Whether does he really have the keen understanding of the metrics, or does he really have the keen understanding of the software, writing optimal software, by asking some sort of a questions to be able, so you can identify the intent, and with that you will have to assume that some things are correct, but you can obviously understand the intent by evaluating well. So that's something that an interviewer has to. I mean, in the current world where with increasing number of podcasts, increasing number of blogs talking about this metrics and everyone else, so I see a lot of resumes these days having those by default. So it's not something that it is very rare. It used to be a rarity, let's say 5 6 years back, but today it is very common for people to talk about metrics, because there are lots of people like me and everyone else talking about it and then evangelizing it. So people are doing it, but and now it becomes a bigger problem for the interviewer to be able to actually identify the right candidates. Maybe they can, maybe they will have to change their ways of interviewing to be able to find the right candidate.
All right. Thanks a lot, Kaushal.
Yeah.
So, where can people find you or follow your insights?
Yeah, people can follow me on LinkedIn,
Okay.
Kausal Malladi. I'm not active on Facebook, but I'm very active on LinkedIn and Twitter as well, which is X now. I should not be calling this Twitter anymore. So people can follow me on those both the platforms.
Sure. Thank you very much. And to our listeners, make sure you follow the Tech Leaders Hub for more inspiring and insightful conversations. Thank you.
Thanks, Sridhar. Thanks for having me. And it's a very great thing that you're doing to try to do a community where you are helping people evolve into tech leaders. I really appreciate you doing this. All the best for your endeavors. And I'm glad to be part of this. Thank you so much.
Thank you. Thank you so much, Kaushal. Thanks. So, see you. Bye.
Okay, bye.